The Pythagorean theorem is a cornerstone of geometry. It describes the relationship between the sides of a right triangle. A right triangle has one angle measuring 90 degrees. The theorem states that the square of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the other two sides, called legs. We can write this mathematically as a squared plus b squared equals c squared, where c represents the hypotenuse and a and b represent the legs. This theorem is fundamental to understanding distances and relationships in two-dimensional space. It's used extensively in fields like construction, engineering, and even computer graphics. Moving beyond two dimensions, we enter the realm of three-dimensional space. We experience this every day. Imagine a room where two walls meet the floor. This corner represents the origin of our three-dimensional coordinate system. The two walls and the floor become our three axes, x, y, and z. Each point in this room can be described by three coordinates, x, y, z. The x-coordinate tells us how far along the wall the point is, the y-coordinate tells us how far along the other wall it is, and the z-coordinate tells us how high the point is from the floor. The Pythagorean theorem, designed for two dimensions, needs an upgrade for three-dimensional space. This is where the distance formula comes in. Derived from the Pythagorean theorem, the distance formula in three dimensions allows us to calculate the straight line distance between any 2 points in space. Given 2 points x1, y1, z1 and x2, y2, z2, the distance d between them is d equals the square root of the sum of the squares of the differences of their coordinates. This formula is essentially the Pythagorean theorem applied in three dimensions. We take the differences of the corresponding coordinates, square them, add them up, and finally take the square root to find the distance. The applications of the Pythagorean theorem and its three-dimensional counterpart are vast and diverse. Architects use it to calculate roof slopes, structural supports, and material quantities. Robotics relies on it for navigation and movement planning. In computer graphics, it's used to render three-dimensional objects, calculate distances between objects in virtual environments, and simulate physics. Understanding the relationship between distances in three dimensions is crucial in fields that deal with physical space. Whether it's constructing buildings, programming robots, or creating realistic video games, the principles derived from the Pythagorean theorem remain essential tools for innovation and problem-solving in our three-dimensional world.